In this video, we're going to continue to look at adding and subtracting rational expressions. In the previous video, we talked about how when adding or subtracting simple fractions or rational expressions, the lowest common denominator does not repeat factors common to both denominators. We also introduced these steps for adding and subtracting rational expressions. So now, let's go through an example. Here's our example. The first step is to factor the numerators and the denominators fully. Well, here the numerators are already fully factored, but we can factor the denominators. First one would factor like this because there's a common factor of x, and the second one is a difference of squares, so we can factor it as a difference of squares like this. Now we need to find the lowest common denominator. So the lowest common denominator needs to include each of the factors, but does not repeat factors common to both denominators. Notice here that we have an x plus 1 in both denominators. That's common and is not going to be repeated. But the x and the x minus 1 are distinct. They're different in the two rational expressions, and they need to be represented in the lowest common denominator. That means that our lowest common denominator is going to be x times x plus 1 times x minus 1. And just as we do when working with simple fractions, we can write that out as our lowest common denominator for both to start with. You could put that x in brackets if you wanted to, but you don't have to if it's out front like that. Now we need to look at what we needed to multiply the denominator by to get to the lowest common denominator and multiply the numerator by the same thing. So over here, the thing that was missing was this x minus 1. We multiplied the denominator by that, which means we need to multiply the numerator by that as well. So we get 2 times x minus 1. And over here, if we compare this denominator to this denominator, we were missing an x up here. So we had to multiply the denominator by this x, which means we need to multiply the numerator by it as well. X times x is x squared. Now we've got our two common denominators. We can write everything over our one common denominator. X times x plus 1 times x minus 1. And we're going to multiply out and combine all of these. Well, 2 times x minus 1 becomes 2x minus 2, and we've got plus x squared. If we wanted to rewrite that in the form that we're used to with descending powers of x, we would write x squared plus 2x minus 2 over x times x plus 1 times x minus 1. Now, it's often conventional to leave the denominator in fully factored form, but to expand the numerator, expand and simplify the numerator. So often you'll see the numerator and the denominator written differently. You might want to check with your teacher to see if they have a preference. Now, the last thing we need to do is to find our restrictions, and we do that by looking at the lowest common denominator. So here, the lowest common denominator occurs in all of these different spots, so we're going to look at that. We could just look at our answer if we wanted to, because nothing has been canceled out here of our lowest common denominator. So we need to identify all the things that would make it 0. Well, looking at this part, if x were 0, that would be 0. So x cannot be equal to 0. It would make this first part 0, and therefore the whole thing. From the second one, we know that x cannot be equal to -1, and you could write the intermediate equation if you wanted to, x plus 1 equals 0, and then solve for that. But we've had some practice now, so we're pretty confident in doing that. And from the last one, we know that x cannot be equal to +1. So we've got 3 restrictions, which we found by looking at our lowest common denominator. X cannot be equal to 0, x cannot be equal to -1, and x cannot be equal to +1. So adding and subtracting rational expressions, you find the lowest common denominator just as you do when adding and subtracting simple fractions, and you find the restrictions by looking at the lowest common denominator.